Hey buddies, welcome to my channel Study Buddy. In this channel, I'll be uploading all the solutions of CBSE Class 10 Mathematics. So let's get started with the second problem from exercise 1.1 from Real Numbers chapter. Question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. They're asking us to prove how these three terms are odd positive. So that's quite simple. So let's check out with the solution. Consider a positive integer. For that, we apply Euclid's division algorithm with q and b. b is equal to 6 here. Since here b is equal to 6, since we have observed in the problem that 6q plus 1, 6 is the b term in this problem. 0 is less than or equal to r and less than 6. So here the value of r can be greater than or equal to 0 but has to be less than 6. Because the value cannot be greater than 6. They are asking us to prove the value only until 6q plus 5. Hence, the value of r cannot be or should not be greater than 6. So, from the above points, I got the equation a is equal to 6q plus r. This is the basic statement or the basic equation to solve the problem. Next step. As 0 is less than or equal to r is less than 6, therefore, the possible reminders from the above condition, the possible values or the possible reminders for r is 0, 1, 2, 3, 4 and 5. Number A can be 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 or 6q plus 5. As per the above equation, just substituting r in the place of all the numbers in the place of r to get these equations. Next, 6q. I am writing this term as 2 into 3q. This 3q, this term, I am considering it to be some integer m. So it becomes 2 into m, that is 2m. As per the above previous step, 6q plus 1 becomes 2 into 3q plus 1. As we derived it here, 2 into 3q becomes 2m. Therefore, 2m plus 1. Next, 6q plus 2 is equal to 2 into 3q plus 1. We get this by taking 2 in common. Here it comes 1 and we are taking 2 in common, 3q. So this 3q plus 1, this term, I am considering it to be some integer n. So 2 into n is 2n. In the next step, 6q plus 3. In the next step, it becomes 2 into 3q plus 1 plus 1. So 3q plus 1 is n as per this step. So it becomes 2n plus 1. Next, 6q plus 4 is the fourth term. So here 2 into 3q plus 2. 3q plus 2, I am considering it to be some integer t. So it becomes 2t. Next, 6q plus 5. Here it is 6q plus 5. So the next step is 2 into 3q plus 2 plus 1. So how do you get it here? 3q plus 2, I took it as some integer t. So similarly, 2t plus 1 is the next term as per the previous step. So we note that 6q, 6q plus 2, 6q plus 4 are of the form 2r. r is the remainder. So anything multiplied with any integer is always an even number as mentioned. Therefore, the numbers like 6q, 6 cube plus 2, 6 cube plus 4. All these integers are of the form of an even number. 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5 are of the form 2r plus 1. Therefore, they are not even numbers and are odd numbers, and hence we have proved the above statement. So we have completed the first problem of this exercise. In my next video, I'll provide the solutions for the remaining problem. So please do refer my channel for further videos. Thank you.